scenario being given, such as this question. So we have here a separately DC excited machine and separately excited machine. So the first thing you have to do is that please draw the circuit. Okay, please sketch the circuit. Even though it being request or not, please sketch the circuit. So if it's separately excited, so you just draw the separate excited. So please perform the exercise together with me. And so if you have any question, you can ask directly. And here. So we draw the circuit and we draft the circuit or sketch the circuit. So key in all the data. And let's say we have here all the data you should key in, and such that you don't have to refer or return back to the question inside the answer sheet or inside the question sheet. So you just can directly answer from your answer paper. Okay, we draw the circuit, key in all the data. We have here 150 kilowatt, 250 volt, 400 ampere, 1800 RPM. Okay. What else we have? There's certain things that you can key into the circuit. So we just key in. Let's say we have here we have here, it is a generator or a motor. And stated here, machine, but is it a generator or motor? You have to confirm upfront, is it a motor or generator, because it involves the flow of your current. If motor, so means that you are delivering the current into the circuit. If generator, mean you are providing the terminal with the current. So this is it generator or motor. See, you can scan through the question stated here. This is a generator. Okay. Generator means the current flow is outwards. Generator. So this is your IL or I armature. And what this is your I armature. IA. Sorry, I punya writing pad sudah out, so you can just type directly. Okay, we have here the values of field resistance RF with 6.5 ohm. So 6.5 ohm. What else? Adjustable resistance of 0 to 100. 0 to 100 ohm. Then field circuit, we have 1100 turn per pole. And so we key in all the related values into the circuit. So what else? 250 volts DC separately excited. So 250 is the terminal voltage. because this VT is our output. VT here is our output. Then what else? So you draw the circuit, you write down all the data given. Then you also can write the equation. We have here equation IA is equal to I load. Then we know that when a generator, so the EA will be the source which will produce IA RA plus VT. And then if you want to rearrange, because VT is our output, so you can rearrange the equation, which is VT is equal to EA minus IA RA. Okay, so this is the corresponding equation you can derive directly from the circuit. What else can write here? The field also IF is equal to VF over RF total. Okay. So equation, draw the circuit, key in or jot down all the information and derive the equation. Okay, we start with the question. So we start with A. So A here, what does it need? So it's stated that P core is given as 100 watt. P friction windage, PFW is equal to 150. You can write here or write up front. So let's say we just write during our answering the question here. Voltage drop, and the VD is equal to 2 volts. Copper loss, stray loss to be considered means that copper loss you have to find the copper find the stray. Also you have to find. Okay, analyze the efficiency of the machine. So how much is your efficiency and how much? When input of P in is equal to 130 kilowatt. Okay. You transfer all the information into circuit data formula derived from the circuit. Then you transfer the data of the question into information here. Then start with A. So N is equal to, when we want to look up for efficiency, so you just restate the efficiency equation, which is P in divided by P out. So please write together with me. If I'm moving too fast, please inform. So P in is equal to N equal to P in times P out over P out times 100%. So this is your efficiency equation. Okay, what else? So we need to find P in is given, we need to find P out. Is it? So P out is equal to okay, sorry, when we talk about finding the efficiency, there is two diagrams that you have to draw actually. One is the equivalent circuit of the system. One is your power flow diagram. So when we talk about machine motor, a generator, so a generator means that you are converting from mechanical into electrical. Okay, so how's the diagram should be? From mechanical to electrical. You draw the diagram, which is, this is your P in, this is your P out. So P out is your electrical. And so electrical, it has only one losses component, which is P copper. Meanwhile, P in is mechanical, so you have three elements of losses, which is P rotation, P stray, and P core. And rotation, stray, core. Picturing this all together over there. So here is your P converter. Even though you are requested to draw or not, please draw for your own reference. So out of this diagram itself, so we can see, or you can write underneath the diagram, which is P out is equal to P in minus all the losses. P in here, we have P in minus all the losses, so you get P out. And so the component of your P losses actually is just a P losses. You can use P converted, or you can directly just minus from, or you can just add up all the losses. It's equal to P in minus, sorry, P losses is the element of P copper tambah P brush drop and plus P friction windage plus P core plus P what? Stray. S-E-R-A-Y, P stray. Core, friction windage, string. So this is your losses component. And this is your losses component. Out of the diagram that you draw, you can then derive directly the equation. Okay. So now, P out here is equal to, even though you already derive up front, please restate during your calculation process. Minus P losses. Which is P in minus P copper minus P brush drop minus, so if you make a so you tambah the losses plus P the Windows plus B core plus B 3. Boleh nampak semua ni? Key in or you click each of the column. P equal to Q what? I square R A. And so this square is write in square mode. Saya tak dapat nak write over here. So this is a square actually. How to make it? Apa you take note lah. This is I. Oh hilang lah. So P couple is equal to again. P couple is equal to I square R A plus I square. This is IA square RA plus IF square F. So how you want to get this values of IA and IF? One moment, please. So IF you have to calculate, and IF you have to calculate. IA also you have to consider the values from the question, which is you can see here input power 130 kilowatts and input power is 130 kilowatt. So you consider as over here your rated current, and just consider the rated current 400 ampere, right? 400 ampere. This is your IA. Meanwhile, your IF, is equal to VF over RF total. Because at this point, we consider unadjustable at 0. and means that the highest RF when the operate higher RF, so that the IF will be very high, the worst case condition. So VF is 250, RF is only how much? The RF 6.5 ohm. So you shall get your value of RF IF of 38.46 ampere. And your IA is 400 ampere. So your P copper is equal to 400 ampere square, 400 ampere square times RA of 0.2 ohm plus 38.46 power of 2 times 6.5 of your RF. And 400 ampere kuasa 2 darab 0.2 of your RA. So RA is 0.2 RA. Where's your RA? 0.2 here, RA. So your P copper B much P copper? Or 1614 watt. So P copper, P brush drop equal to V brush drop times V brush drop times I amateur, which is equal to 2 times 100 ohm, 100 ampere, is equal to 800 watt. This is your brush drop losses. So we have calculate for P in, P copper, P brush drop, P friction and windage is given. It's not. P core is not considered or not, don't have to be considered. P stray So usually we have pre-stray to be considered. So it should be 1%, and 1% of the P-in. Satu tiga what? So P out now you have equal to how much? P in 130 kilowatt minus all the amount there. $150 of P brush drop. Sorry, for 800 P brush drop. 800 brush drop. Friction and windage. Friction and windage. 150. P core 0. Plus P stray 1300. What else missing here? Brush drop 800. P core, yeah, P core is given on the white. So how much the amount? So this is the final P out value. And this is your P out. Means that your efficiency will be N is equal to P out divided by P in times 100%. Which is equal to 86135 divided by 13000 times 100%. So it's equal to how much? Semua available ke ni? Nak sunyi je lah. Semua sedang khusyuk
Sir, PR saya macam dapat lane lah sir.
Dapat
86036.
86
036.
036. So komponen mana yang lain dalam tu? P3, P out, P copper, P brush block, P friction windage. Yang mana yang silap? Yang mana yang ni? Yang termissing. Because saya punya key in data yang silap.
Yang P losses saja saya dapat 43964. So dapat 43864 kan.
Yang mana lah? P losses. Dapat
Kan
apa?
43964. Saya dapat 43964.
43964. Sekejap tengok. The other macam mana? 800 50 tambah 17. P 41614 betul ke? Ke ada lain? 41614. So we have kalau betul 41614 plus 800 plus 150 plus 100 plus 1300, so become 43964. Oh betul lah, 43964. Saya mikir silap kan? 100, 15, 100, 13. 43964 should be 43964 here. Four, 3964 what over here. Or 3964. So answer will be 86035. Huh? 65, sorry. 86035. Huh?
036 sir. 86036.
36.
Dah dah 860365 tu dah dah. Okay.
6036. So dapat efficiency apa? Efficiency kan dia. Enam 6.18.
Sama.
6.18%. Sama macam dalam skema tu lah. So kalau kita tengok di sini, 7 markah mewakili jalan kerja yang lebih kurang satu muka lebih ya. Kalau ditulis cermat-cermat satu muka. Nampak tak? So satu muka. So means that answer dengan jawapan ni mungkin satu markah. Satu. So each of it, part of it akan dapat satu markah. So dia akan mewakili 7 markah untuk bahagian ni. Even though this semester your formula being given, it is better for you to restate dalam calculation. Kan? Sebab kita tahu, you ambil formula dekat mana, dia akan menjadi value tu dekat mana. Kan? Kalau you just state the value later, buat formula you tulis dekat awal-awal dia punya jalan kerja tu, kalau value silap, so there is no alternative to give marks lah. Jadi kalau kita tahu you pakai formula ni, but you have a type error somewhere, and end up your answer is wrong, or your deviation values, so still we have to buat. Okay, soalan bahagian ni. A. Bahagian A.
Sir, time kira IF tu kan,
Kita,
R
ya.
total tu, R
Ya.
adjustable tu kita assume 0 lah sir. Yang
Okay, kalau dia bagi, if they give the values where to set, so just use the setting values. If not, we shall consider worst case scenario whereby the setting is at 0. Means the setting at 0, lowest resistance, it will flow the highest current. Worst case scenario is higher current. Highest current achieved when the resistance is lowest possible. So lowest possible means you set at 0, adjustable. It remains only your original RF. And so this is remaining resistance of your field. So the highest IF will flow. So it will emit the highest sources. If given, so use the value. If not, set at 0. Okay.
okay sir, faham.
Okay, ada soalan lain? Okay, if not, you try to do the second question, but we take a break for 20 minutes. So I want to go for player soalan. Zohor player first. So you also can go for. We come back at 2:05. Okay, 20 minutes break. Okay guys, welcome back. Senyap bunyi ya, sudah apa pun tak ada. Semua faham ke? Okay. All okay.
Okay, sir.
Okay. Okay, we shall continue with question B. See if we have here adjustable resistance set at 65 ohm. We have 0 to 400 ohm of 0 to 100 ohm of frame or range. Now we set at 65 and set at 65 ohm. Then instead of 1800 RPM rating, we just take the input is rotating at 1650 RPM. So we connect the system onto 360 ampere load. And so we have armature reaction of 550 ampere turn. So how much actually the terminal voltage will drop? So if you draw the circuit, the response, so V at no load versus V at full load, for sure it will drop. At no load, we have a higher voltage output, but when you connect the load, so it will drop. So how much actually the drop? And some more, if you have armature reaction, so it will drop further down. And so actually how much the end voltage, and the end voltage or the terminal voltage, and when we have such a situation. So what you have to do is that we start with finding what are the effective field current at this moment. So IF now is equal to I field star, which is equal to I field of previous I field of initial minus armature reaction over number of field turn. So this is the equation that should be we should find. But at this time, IF, which is equal to VF over RF total, is equal to 240, is it? Sorry, 50, sorry. 50 over RF total you sekarang adalah 6.5 plus 65. We have Sorry guys, connection lost sekali lagi. Hello?
Ya, saya. Connection lost sedikit.
Connection lost ah. Sorry, saya memang sorang-sorang nampaknya. Sekejap, nak tengok balik mana pergi tadi. Boleh nampak ah? Dekat mana saya terlemis tadi?
Kat 3.5 ampere tu.
3.5 ampere. Oh, awal-awal tadi lagi.
Ya.
Dia. Tak apa. Kita nampak screen
Nampak
ah.
tu.
Okay. First, kita akan calculate sebab kita ada dua scenario. Satu with compensation. Satu lagi without compensation. Okay. With compensation satu. Satu lagi without compensation. So we proceed with compensation first. Means that kita just have to calculate kita punya IF. You can see here, IF equal to BF over RF total. F kita set dekat adjustable kat 65 tambah dengan R field 6.5. So kita dapat 3.5 ampere of our field current. Betul. Then that field current we probe to the curve. We can see that it produce generated voltage of 340 volt. So this curve kita pakai ni. So they can produce 3.340 volt over here. And then we insert, consider it at just now at 1800 RPM. But when the rotation change, so we find out what are the generated EA at this 1650 RPM. Pada. So kita akan dapat 311.67 volt. Once we obtain the corresponding generated voltage, so we consider at no load how much actually the voltage and we reduce. So at no load, I armature is 0. So we get 311.67 output. And so it means that there is no voltage drop across armature resistance, so voltage will maintain. Then when we apply 360 ampere of load, so we can see that certain values of current when passed through armature resistance, so dia akan ada 72 volt drop across that armature resistance. So remaining dekat terminal voltage 239. So this is the V loaded, V open circuit at no load, and also generated voltage dekat 3.5 ampere of our current. Boleh? So consider the with compensation first. And after that, only we consider without compensation. Okay, just now with compensation, now without compensation. Anybody have any concern? You please highlight. And don't wait until the end of the session lah. Kalau kita takut lepas. Kita ada lagi setengah jam saja lagi. So without compensation, so IF become IF star lah, which is equal to IF original that you have calculate minus the armature reaction over number of field turn. So IF we have calculate just now 3.5. Armature reaction is 550 ampere turn. Ampere turn divided by how many turns of this circuit at field is now 1,100 and 1100 turn. So you will get 3.5 minus 0.5 ampere. So remains as 3.0 ampere only. So with this 3.0 ampere, we take a look at the graph again. So it will bring you to which curve or which values? 3.0 and 3.0. 3.0. Let's say this is the value that you consider 300 volts. So 300 volts. So you shall get from the curve, so it will be EA naught equal to 300 volts, which your N naught of 1800 RPM. Just now 340. Now it becomes only 300 volts. And so same steps follows. So, but at 1650 RPM, what happened? 1650 RPM. You write again your EA, which is divided by EA naught is equal to speed at this moment over speed that you reverse, which is a naught. So EA one moment please. Okay, continue. So we key in the data that we have calculated. So N is 1650 over 1800 of our reference. So you shall get your EA of how much? Berapa dapat? Anybody? Anybody?
275.
Alright, betul. 275 volt. Thank you. So that is your EA at 1650 RPM. And so you consider again. Now at no load. At no load condition. So your IA is now 0. IA is 0. And at no load, your IA is 0. So you use the equation which is Vt is equal to EA minus IARA and your Vt at no load is equal to EA minus IA at no load times RA. Well, you have to write again and again in this examination. You have to write. If you lazy to write, let's say you have a typo error or data which is incorrect, so your marks also tak flat. So better make it longer such that you are capable of getting marks out of your work lah. So now your EA is 275 and your current is 0. So from 0, so equal to 275 volt. Okay. So let's add no load. Then when we apply load, at IA is equal to 360 ampere. So this VT applies also. And we shall have VT at 360 is equal to EA minus IA of 360 times RA. Shall get your terminal voltage of 275 minus 360 times 0.2, which is equal to 275 minus 72, which is equal to 203 volt. So that's the answer. So evaluate the terminal voltage with compensation winding and without compensation winding. Let's say if you are requested to draw or compare, so we can sketch a graph. So you just label and sketch a graph, label, and if it needs you to find out the what so-called because this is the output of your generator is rotation. So means that your SR lah. So you have to find your SR. So just compare between the SR of before how much content. So maybe 4 marks for calculation, 4 marks for this calculation, another 1 mark for your comment. And you say compare between without compensation and with compensation winding. Any question? That's for B. or B? Ada soalan lagi untuk bahagian satu ni? Ada soalan?
Tak ada, sir.
Oh, we have C. Oh, we have C for this question. Yeah. Using machine.
Utama, jangan main game. Hari sekolah kau main game, dah tak pergi sekolah. Betul?
So for C, can see here the question stated, suggest improvement that could be made for the machine to restore the terminal voltage into its no load value found in B and calculate the required field current and adjustable resistance to restore. Assume that it has compensation winding. So here, assume as compensation windings being applied. And so, how you want to, or where to start with this question? So we started over here that we have to increase. And so C, VT to up into VT no load. So what happened? So how you want to adjust that? So when you refer back to the equation that we have generate, or we have derived before, see, this is VT, which is equal to EA minus IARA. So you can write over here, VT is equal to EA minus IARA. So you can discuss, or you can explain in theory. And for VT to increase, need to be increased. For flux to be increased, for flux to be increased, so for flux to be increased, I feel need to be increased. Typo error, kena ulang jangan buat typo error. Ijaz tak apa. So I have to be increased. So to adjust RF, to adjust IF, we can adjust either VF or what are adjustable. Okay. So this is the theory. And so you can write the theory, or you can put in what so-called dalam notation, and pun boleh. Means that if you want to increase VT, see here, to increase VT, maybe you have to increase EA, katakan. Ini notation lah. So you have to increase, let's say, flux, and or you can write a statement, and either one lah. As long as your audience can understand what you will try to say or try to deliver, it's okay. This is theory. So theoretically, you have to increase, but in fact, how much in terms of their increment? And so how much in terms of their increment? So that one you have to calculate. So you start with calculation. And for VT, it is equal to the just now in B. In B, we calculate that VT should be how much? V terminal. So this is your V terminal node 311.7. 311.67 volts. So this one, at this moment, EA is equal to VT plus IA on A. So EA of this time is equal to 311.67 plus at full condition of 360 and 0.2 up, and so you will get your EA of 311.67 plus 72 volts, which is equal to 383.67 volts. So the scenario here at IA equal to 367 ampere. This is scenario for VT to reach or to maintain at 311.67 volt at IA is equal to 360 ampere. So you have to abide or to follow the same equation of this equation. So EA at this moment is equal to 383.67 volt. This is your required EA. And then, but the equation is that after that is EA over EA naught is equal to speed over initial speed, and which is, now we have already the EA 363.67 divided by the EA naught that we have to find for this moment to produce that output terminal voltage with the rotation of, we have not changed from the previous scenario, which is 1650. So we can calculate what should be the required EA naught at this moment. So dapat apa EA naught? Berapa? $418.54 kan? So this is the required EA. Then what you have to do? So this is the reverse process of what we have calculated to find the VT. Now we reverse the calculation to see how much actually we have to adjust our art adjustable. And just now the process is we have art adjustable. So we calculate to get how much is our VT. Now VT is given, so we have to reverse the process to get how much our art adjustable. Nampak tak? So what's the next step? Please use the graph. And now we have to reverse the process, which is from this graph, how much your EA naught, you try to see how much actually your required IA. And with your EA naught, how much actually your required IA. So you can see here from the curve, you can see that your IF is equal to, with this 418.54 volts and 400, 500. So here will be 450, 425. So 418 is around here. So it should be around here. And 418. So we go to about how much? 5 ampere. We can get 5 ampere lah. And so we get 5 ampere. Let's see. So this is your result. From the curve, IF equal to 5.0 ampere. And so IF equal to 5.0 ampere. So IF again is equal to BF over RF total. So 5.0 is equal to BF is maintained at 250, does not change. Your RF is how much? Your RF is the amount of your initial armature resistance, which is 6.5 plus your art adjustable. So now let's find the art adjustable, which is how much? The art adjustable for to all to get is 5.0 ampere. So correct not? More or less 43.5. Lebih kurang. So settle for question C. So briefly discuss on the theory concept. So you just discuss up front, or you can discuss at the end of this calculation. So you can discuss in terms of the fact. So you say, let's say now you state the theory, so just discuss the result. So for VT to increase to 311.67 of the system, previous values, at current values of armature at 30 ampere. So you need to get the internal voltage of 383.67 volt. But to complete that, you have to get the initial generated voltage of 418.5 volt values, and from the curve, this internal generated voltage need a 5.0 ampere of P current. So to get this 5.0 ampere of P current, you have to adjust adjustable resistor into 43.5 ohm. So that is your comment. Means that whatever you calculate here, you just translate into a paragraph. Okay. But so that's all for question number 1, which is actually each of question that being asked inside your exam, you should be able to complete within 40 minutes of duration. 5 minutes for cross check. And discussion mungkin makan masa lah, tapi when you perform your practice again and again, you should try to complete by 40 minutes, because 5 minutes you provide to revise again and to see maybe you have a type error whatsoever lah. Okay. So that is the process. Any question? Ada soalan?